Hello and welcome to my channel Infowars Tech, where we explore new technologies including big data, machine learning, artificial intelligence, and similar. So today we are going to look at R, which is a fabulous, awesome project in software which allows us to manipulate data. Today we'll be looking at some basic functionality, but you will get an idea of how powerful R is, and I'll follow it up with a more detailed or advanced tutorial where we will be accessing files using the inbuilt datasets and show how easy it is to manipulate data using R. So head over to rstudio.com and download RStudio. I already got that running on my desktop, so I'm just gonna fire that up. And as you can see, once it comes up, it's actually very well laid out. So on the left hand side you have what is called a console, where we will be entering our commands to run R, and in this right window on the top right you have some information about the environment, some history information that you've been running, some commands, some connections, or you can also look at tutorial about any command or any function that you want more information on. In this larger bottom right hand corner we have what is called you can look at the files that are in your folder structure. You can do some plots that will be visible here once you run them. These are the library packages that you can install, so amazing way to just search and add, and it'll become part of your R ecosystem. You have help and also a viewer. We will look into these at a later time. So let's get going, and I'll leave it here or at the help section. So to start off, let's start with help, and let's say I'm starting off, so I need help with a commonly used function, let's say mean. So I'm going to just say help. I'm going to enter what I'm interested in, and this IDE actually prompt you as well, so you can say generic function for the trimmed arithmetic mean. And if I hit enter, on the right hand side you see that it provides very detailed description, and this is really helpful if you don't know how to use a command or a function, and you can easily find the help for that. Another way to find this information is to do a question mark and the function that you're interested in, and that also gives you a similar. Let's run that. So it'll give you the similar to help mean. You can also see what arguments are required for this function in particular. So it will tell you that you need these are the parameters you need at minimum. Let's look at another great help feature here. So I can do example mean, and it'll actually show me examples of how this function can be used. So I find the example function amazing to find more details and actual working examples of that function that I'm interested in running or knowing more about. Okay, so let's take a look at a very important data structure for R, which is called a vector, and it's a central component of R, and it can contain numbers, strings, logical values, but not mixed together. So let me create a vector of numbers as an example. So the syntax is C, and I can follow it with some numbers that I want. Let's say some even numbers, just as an example. So this creates a vector, and you can see that it's now 2, 4, 6, 8 are part of that vector. I can also move it into a variable. So let's say C1 or anything. It can be V1 equals C 2, 4, 6, and when I run that, it accepts that, and I can just run v1 and it shows me the vector that I created. Now the good thing with the R Studio IDE is that I have history, so if there are longer commands I can just go back and rerun them. So makes it very convenient, especially if you have a very long function that you've written. You don't want to repeat that. Okay, the next thing that we want to look at is some more ways of generating vectors. So let's take a look at one that generates some numbers, and you can see it will actually create, and there's like an equation in between, and it's creating those numbers based on the arguments that you provided. So 1 to the power 1 into 2 to the power 1 gives you 2, into 2 to the power 2, which is 4 into 8, and so on. So you can generate different kinds of numbers and sequences. Let's look at another. So as we mentioned, a vector can contain numbers, strings, or logical values, but not mixed together. So let's run our typical hello world, and let's see how that works. So hello world, and it's a vector showing hello world. Let's see a shortcut of generating a lot of numbers. So I could say, and this vector will generate all the numbers from 1 to 50. And the good thing to note here is that doesn't use 0 as the first element. So when we start referencing the numbers in a vector, it'll be as you count. So 1 stands for the first element, second for the second element, and so on. Let's look at some other ways to generate a vector. So I can do a sequence, and I can generate, let's say 1, 4, and I want it to go in steps of let's say 0.25. So I'm just making these up, and just to give you examples of what is possible. So here we see that it goes from 1 to 4. 4 is the last value, 1 is the starting value, and it increments in 0.25. So 1, 1.25, 1.5 till it hits the maximum value. I can rerun that again with, let's say, changing this value to, let's say, 0.33, and the result is much different. So 3.97 is the last value, because after that it goes over 4, which is our maximum number there. So a great way to generate numbers. So let's look at some other examples, and the idea is to give you a very good background on how you can create numbers, generate numbers, and start to use R in your data manipulation and data analysis, and use it as a tool. Let's look at another function called repeat. So here I have two numbers, one is 1 and 2, and I'm saying repeat this 4 times, and let's see what the result is. So it repeated 1, 2, that sequence 4 times. Another one, and here instead of times we say each of them 6 times. So you see the difference, that each number, 1 is repeated 6 times and 2 is also repeated 6 times. So very interesting ways to create different sequences, and it all depends on the different types of use cases you might encounter in your data analysis, your life as a data scientist. So let's look at some other sequences that I had. So let's show you how to combine vectors. So C1 equals some vector C1 and 5, so that's 1 to 5, and I have another vector C2, which could be let's say a sequence of numbers. So we could do, I'm just making these up, you can try with different, it really doesn't matter, we're just trying to learn here. So that's C1 and C2. If I run C1 C2, it'll show me that sequence. So let's quickly do that, so we know that we generated some numbers there. Now how do I combine them? I just do I make a new vector called C1 C2, and I just add these together with a comma in between, and these vectors are now added. And oh sorry, I'm sorry, it should be C1 C2, just a name I give, and it generates a combination of those two. Okay, what are we doing here? Sorry, you have to always add C for a vector. Okay, so C1 C2, because C denotes a vector. So there you go. So now our C1 and C2 are combined as a vector. Let's look at another, which is sorting it. So let's sort this C1 C2, and you see that it changed it to from in ascending order, so minimum to maximum. Let's look at another, so reversing C1 C2, and what do we get? We get actually this, so C1 C2 reverses what was originally C1 C2, not the sorted one, remember. So it reverses what C1 C2 was originally. Okay, we can also run something called table, which will count values. So let's see how this works. So okay, so it found one instance of 1, 2 of 2, 1 of 2.65, 1 of 3, and so on. So very interesting. If you're analyzing text or numbers, this will give you a count in just one command. Amazing, very, very powerful. We can also do unique, and we can see if there are any unique numbers in this vector, and indeed these are all the unique vectors. So if you had two, so we have two twos, it just shows you one, so it's just the unique numbers. So again, extremely powerful, and there are so many use cases for these two commands that I showed you, table and unique, just now. Okay, let's look at selecting these vector elements. So let me see. Okay, let's take a look. Let me just make this a little bigger so it makes it easy to see. Don't want to go to the bottom of the screen. Okay, so we were doing selecting vector elements. So let's say the syntax is C1 C2 and square brackets and some value x. So let's say let me enter some number. So let's say I enter 4, or I enter, let's say, 2.65. Okay, so it tells me that the location or where it is. Let's see. So let me run this again to see what C1 C2 is actually. Okay, so next we want to look at another similar syntax, C1 C2, but in this case what we are saying is show every element except the one that's listed here. So if I say -3, so it's going to show every element except the third element. So if you notice here, the third element was, this is 1, 2, this is the third element, 4, 5, 6, 7, 8, 9, 10. These are 10 elements total. So when I say show me everything except the one that is in position 3, or element number in position 3. So it took out 3 but showed everything else. Let's try another one. Let's say with I want the ninth one, so everything except the ninth one. So when I run this, I shouldn't see 3.95. This should not appear in the output there. So there you go, right? So by position you can say, okay, every element except this element. We can also do something interesting here to say, let's say 3 minus 5. This could be confusing. So this would result in -2, and the result is the second element show everything except the second element. So if I run this, you notice that the second element 2 is removed and everything else is shown. So just another way to generate some numbers, or to see how the vector is accessed. Let's look at something else, which is a range. So C1, C2, which is our vector, and I want to look at all the elements in these locations. So it picked up 2, 3 and 4, right, which were corresponding to 2, 3 and 4. So 2 is to 4 means 2, 3 and up to 4. If we just increase this range, you'll notice that it has more numbers. So it picks up the second number all the way to the 7th number in that element, in that vector list. We can also slightly modify that to say, let's say here, and we want to say minus. What this will do is very similar. Every element except between 2 and 4. So you notice that you got 1, then 2, 3, 4 are missing, and then the rest of the. So again, very many ways to manipulate data, and I'm sure there are some use cases that you can find, and this function will help you do that, or the way we're doing this. Let's look at some other ways to do this. So I can also do C1, C2, square brackets, and some numbers here, so 3 and 4, and close it off, and so it gives us the numbers 3 and 4. Let's look at some more interesting, equal to some number. So if I run this here and I say C1, C2 equals to, let's say 3.3. I see that number there in the vector list. So it's able to, if you're looking at the use case, could be there are millions of numbers and you just are interested to see a particular number in which location it is, you can find that number. Or you're looking for a number in a text or a word in a in a dictionary with millions of words or entries. This can help you find that very quickly. We can also do some kind of comparison. So I can do C1, C2, show me all the numbers that are greater than 2.1. So it shows you all the numbers that are greater than 2.1. I can also do show me all the numbers that are less than 2.1. Right, just immediate reverse of that. So it shows you 1, there's 2, the 2 2s, and all of these. So 3 numbers less than 2.1. Very interesting, very quick to implement. Let's take a look at another which just briefly touches upon sets. So this command, I'm just going to write it, make it quicker. I have that already written. So this will find those elements defined by the set 1, 2 and 5. So let's run that, and you see that it in the set 1, 2 and 5 you have one element of 1 and 2 2s and 1 5. So we know in our vector there are actually 2 2s. So because they're defined by that set, it prints those out. Very simple, very easy, and to manipulate that data. Let's look at we said the vectors can contain text as well. So just the slight difference here, that when we are creating a vector for these text, you have to have this arrow pointing to the variable that you select. So let me run that, and let's double check to see if it has the values right. So it got apple, pineapple, banana. I can do some search in them, so I can search for some element here. So I can use grep. People familiar with Linux or Unix world would be able to recognize this command, which means to be able to search and match. So I'm just searching for PPL to text inside fruits vector, and let's see what comes out. So it says you have a match in element 1 and element 2, and which is true because I'm matching it here in element 1 and I'm matching it here. Okay, let's take a look at another one which is actually a substitute. So let's try that, and this is all in fun, so go ahead and try on your own as well. So I'm taking the same PPL text, and the command is gsub, so this will substitute. So find all instances of PPL and change them to apply in the vector fruits. So when I do that, you notice that it changed the PPL to apply in all places that it can find. Again, fantastic use cases. You want to change in a file, you want to replace some text with the other, one command, one function will do that. Amazing flexibility. Let's look at some math functions, and we're coming to a close. I wanted to keep it very short because this is just an introduction, but when you come back to the channel with an advanced tutorial, make sure you have RStudio IDE installed and you go through this introduction, and that should spark an interest. Okay, so let's look at some math functions. So C1, C2, if I'm looking for the max number or the biggest number in this vector, I run max, so it tells me 5 is the biggest. I can also repeat this with min, and it'll give me the minimum number, which is 1. That is correct. Let me generate a sequence just to make it interesting, and I'm gonna name it NBRs or numbers. So I'm creating a vector with a sequence. It's 1 to 5, and you can see the step is 0.054, so 3 decimal places, right? So let's run that, and NBRS for confirmation. So you can see it generated a whole lot of numbers. These are all lying between 1 and 5. You can see the last number and the first number, so they're all lying between 1 and 5, and you see so many numbers because the step is very, very small. It's 0.054, so that's why we see so many numbers. Okay, now let's do some manipulation on these. So let me round it. So the R function is called round. It takes 2 arguments, so NBRS, which is our vector, which I just showed you here, and 2. That means round it and round it to 2 decimal points. So when I run this, all of these numbers will be converted into 2 decimal places instead of 3, which we have right now. So, and before I run that, let's see what arguments tell us about this. And so it tells us that a number, the vector, and you can specify the digits. Okay, let's run that. So round, I have the vector, and I want to do just 2 places. So you notice it converted these 3 decimal places to 1. Now if I run that again, and instead of 2 I want a single decimal point. Again, I can think of hundreds of use cases where I would be needing this amazing function. So you notice that it converted all of them to a single decimal place. So again, very versatile. Let's take a look at an interesting function called sum, and all it does is, if you specify the vector, it will sum it across all the elements. So we get this is the sum of all the elements in this vector. Let's take a mean, and we know what a mean is. Mean is the middlemost value in a data series. The mean function calculates the arithmetic mean. So that's the arithmetic mean for all these numbers that we see here. And the other one that I want to run is median. So median is the middlemost value in a data series is called the median, and it would be, I imagine, close to the mean. So mean is 2.98 and median, oh interesting, it could be different as well. But yeah, median is the middlemost value in that data series. We also have something called rank. Rank actually is what it's called. It references the position of the value in the sorted order, sorted vector, and is in the same order as the original sequence. So when you run it on this vector, it will display what it sees as the original order of the sequence, right? And order, so since we haven't changed this, we should see it the same. So we have 75 values and just rank them accordingly. But once I sort this, I get those from starting from ascending order all the way to the largest. And if I run rank now, it should still be the same because we haven't really changed the order of the original sorted vector that we had. And order, which is similar but slightly varies from rank, is where it returns the position of the original value and is in the order of the sorted sequence, that is smallest value to the largest value. So this was a quick introduction to R, to get you familiar with R, its functions, and how easy it is to manipulate data. And as I said, I'll be following up with an advanced tutorial on R, where we will be covering the built-in datasets, some advanced libraries, and also look at some advanced functions like if then else. We'll be looking at matrices and other advanced functions from R. So stay tuned and keep coming back to the channel. Your support matters a lot. Thank you very much, and enjoy using this